Hi, my dear friends. Welcome back to another Python tutorial class. And in this class, we shall see the remainder part regarding compiler and interpreter of the Python environment. Now, the first cell you can see, the title is Compiled Languages versus Interpreted Languages. We have already discussed what is a compiler, what is an interpreter in the previous class. If you have not watched out that video, then kindly check out that video. So compiled languages are like Java, VB. VB means Visual Basic. C++, C. These are the compiled languages which simply use compiler as the translator. Okay, we know what is a translator. A translator is a software and that is used to convert high level language into low level language and vice versa. And compiler is a type of a translator and interpreter is also a type of a translator. Okay, so compiled languages such as Java, Visual Basic, C++, C, these are the compiled languages which use compiler as the translator. In contrast to interpreted languages such as R, Python, PHP, which use interpreter as the translator. Okay. However, in Python, we do have the combination of compiler as well as interpreter also. Okay. So this statement basically means that Java, VB, C++, C, these are the compiled languages. Languages which use compiler as the translator are known as the compiled languages, and languages which use the interpreter as the translator are known as the interpreted languages. For example, R, Python, PHP. However, in Python, we use intermediate like in the inter. If you go, then there is a combination of compiler and interpreter. Now, what is the source code? This we have discussed also in our previous class. The main program that we write, being the users, or that I write as being the user, which is the high level language, is known as the source code, and the extension is .py. This .py is the extension of the source code. Okay, so like here in Jupyter Notebook, we write the source code. So the main program that we write, which is the high level language, is the source code. And the extension of the source code here is .py. Okay. Then what is an intermediate code? Again, when we execute the .py file, that is the source code that we have, which is in the .py format, when we execute this, that is the source code, then compiler comes into action, and this compiler, what it will do, this compiler, it will read the whole source code at first, the entire source code. The compiler will read at first the entire source code and then convert this source code into intermediate code, and intermediate code is also known as your bytecode. Extension is .pyc at once. We already have discussed what is a compiler. Compiler is a translator which will read the entire source code at first and then convert it into machine code. That is the generic definition. But here in Python, like when we first execute the .py file, which is our source code, then the compiler will come into action and it will read the entire source code at first, and then it will convert this source code into intermediate code, which is also known as bytecode. Extensions .pyc at once. Okay. However, if the compiler grabs any error, like any syntax error or indentation error, if the compiler grabs any kind of error like that, then it won't convert the source code into bytecode and no output will be there. So it is better that when we write the source code to ensure that there is no syntax error, there is no indentation error. Otherwise, no output will be generated, error will be generated because the compiler won't convert the source code into intermediate code. Okay, and then comes your machine code. What is machine code? Now, suppose everything is perfect, the compiler couldn't grab any error. There was no error to be caught by the compiler, and hence there was the smooth conversion of the source code into intermediate code by the compiler. And now what will happen? That's what I've written here. That's what I've written here. However, if everything goes right, then conversion will happen. That is, the compiler will be able to convert the entire source code into intermediate code at once, because we know compiler will read the entire source code at first and then convert it into intermediate code at once. And if there is no error, conversion will happen smoothly. And once this happens, there is the source code from .py extension is converted into intermediate code, that is .pyc extension. Then what will happen? The interpreter will come into action and it will read the intermediate code line by line and convert this intermediate code into machine code one line at a time, because we know that here, as I told you, there is a combination of compiler and interpreter. So overall, the source code, which is in .py format, that will be read by the compiler at first, the entire one, and then that shall be converted into intermediate code, that is byte code, that is .pyc extension at once. And since smooth transition has happened, no error has been caught, then the interpreter will come into action. And the interpreter, what it will do now, right now we have intermediate code, because the source code has been converted into intermediate code. So then this interpreter, it will go through this intermediate code, it will read the intermediate code line by line and then convert it into machine code one line at a time. Okay. However, if the interpreter grabs any error, then it won't execute and read any further. Okay, it may happen that interpreter, it is reading the intermediate code line by line, no issues, converting into machine code one line at a time, but suddenly a situation arrives where there is an error, there is some sort of interpreter error. Okay, and then what will happen, then the interpreter, it won't execute and read any further, it won't proceed any further, and here in this case we will get the output, but until the error is grabbed by the interpreter. So as long as there is no error, the conversion will happen. Otherwise, as soon as any kind of error occurs or caught by the interpreter, then no more no more execution will happen, it won't read any further, and here we shall get the output, because there is the interpreter right now, we shall get the output, but until then, when the error is grabbed by the interpreter. Okay, then classification of errors, this one, there are two types of errors, one known as compile time errors and the second one known as your runtime errors. Okay, compile time errors and runtime errors, these are the two types of errors that we mainly counteract with. What are compile time errors? The name only suggests when the compiler grabs the errors during the compilation time, then those are compile time errors. Examples: syntax error, indentation error. Okay, so the errors which are caught by the compiler while the compilation is happening during the compilation time, those are known as the compile time errors. And examples are syntax error and indentation error. And then you have runtime errors. Okay, runtime errors are the ones which are caught by the interpreter. So that's what I've written here. When the interpreter grabs the errors during the runtime. Okay, runtime, as we already know, what is a runtime? When the interpreter comes into action. Okay, so when the interpreter comes into action and supposedly it grabs errors during the runtime, then those are known as your runtime errors. So runtime errors also have classifications like value error, name error, index error, type error, division by zero error, attribute error, key error, file not found error, module not found error, overflow error. These are some of the examples of runtime errors. So there are compile time errors, runtime errors. Compile time errors are the ones which are caught by the compiler during compilation time. For example, syntax and indentation errors. And runtime errors are the ones which are caught by the interpreter during the runtime. Those are runtime errors. For example, value error, name error, etc. Okay. Then, for example, here you see in this code, x is a variable to which value 15 is assigned. 15 is assigned to this particular variable x, and 25 is the value assigned to this variable y, and z is equals to x plus y. So print z. I have written here. Okay. So there is no problem up to here, up to line number 4, everything is fine. Z is equals to x plus y, 15 plus 25, that means 40 should come out. But after that, I've written here something like Python, print Python, and here I've given just one, just one single inverted comma. Here there should have been another inverted comma like this. Okay, so if I print this, if I run this cell, shift enter, then you see no error, no error, because z is equals to x plus 5 means 15 plus 25, 40. That's what has been printed here, the value of z, and also the string value, which is Python, has been printed here, which is this value. This is a string value. Okay, now whenever we are trying to directly print a string value in Python, then it should be enclosed within the inverted commas. Like here, if you have inverted comma, here also you should have a closing inverted comma. But if I remove this closing inverted comma, then this becomes your syntax error. As I told you, compiler's job is to read the whole source code at first, and then it shall do the conversion. That is, it shall convert into intermediate code at once. But if it grabs any kind of error, that is compile time errors like syntax error or indentation error, then no output will be generated. No output, only error will be generated. So this is a syntax error. In this case, even though we are expecting that at least this one is fine, so for this we should get an output, but that won't happen. Compiler won't allow that, because this is a syntax error which is a compiled which is a this is a syntax error which is a compile time error which will be caught by the compiler during the compilation time. So if you run it here, you see no output, directly we get syntax error. Okay, then if you come to this particular line, to this particular cell, print Python. Okay, here you see Python is enclosed within single inverted commas. Then you have x value 15, y value 25, z is equal to x plus y. No issues. Print z. Okay, print a. That is capital A I'm talking about. If you see any kind of variable is there by the name of capital A in this particular cell, no. Then print welcome. Now see, welcome is also enclosed within single inverted commas. You have opening inverted comma here, and closing inverted comma also. Opening single inverted comma here you have, and closing single inverted comma also you have. Here also here opening single inverted comma you have, and closing single inverted comma you have. So as I can see here, there is no there is no syntax error, there is no indentation error also. Okay, so as far as the knowledge goes, there are no compile time errors that should be caught by the compiler here. So in this scenario, the conversion should happen smoothly. That is, the compiler should be able to convert the source code into intermediate code, and after that the interpreter will come into action, which will read the intermediate code line by line and convert it into machine code, one line at a time. Now as you can see here, the variable capital A is not declared anywhere here. So up to this one is fine. Python within there is string within single invert commas, fine. X defined 15, y defined 15, z is equals to x plus y, fine. Print z is also fine. But this capital A is not defined anywhere. So this will be what error? This will be your runtime error. This will be your runtime error that will be caught by the interpreter during the runtime. Okay, so if you run this particular cell, you see at first Python, this one is printed fine. Then z z is equals to 15 plus 25, that is 40, and trying to print the value of z, which is 40. Okay, but as soon as the interpreter comes to this particular line, here it will check that where is this particular variable capital A. This variable capital A has not been defined anywhere in this particular cell, or previously in any other cell also. So that's why it will see that this variable has not been declared anywhere. Declared means some sort of value should have been assigned to this particular variable. That's not happened. That's why here this name error has occurred. As soon as you try to run this particular cell, then this particular error appears, which is your name error. Here you can see indication has been given that the error has occurred at this particular line number 6. Okay, and the explanation is also given, which is your name error. Name A is not defined. Oh, okay. As we can see, name error, this name error, it falls under which kind of error? Mainly name error falls under runtime error. Okay, so here there was no syntax error, no indentation error. So compiler was able to convert the source code into intermediate code at once, and then interpreter came into action. Okay, that is here no syntax error, no indentation error. So in this case, the transformation happened smoothly by the compiler, where it read the whole source code at first, converted it into bytecode, that is intermediate code, at once, and then the interpreter came into action, where it will convert the intermediate code, that it will read the intermediate code line by line and convert into machine code one line at a time. So internally, what's happening? The interpreter catches the error here. Till up to here, there is no issue. That's why we are getting the output also just before this particular line. So that's why the statement was written that output will be generated whenever interpreter catches any error, that is runtime error. In that scenario, output will be generated until the error has been grabbed by the interpreter. So just before this, no error was there. So before this, whatever output was supposed to be done, that will be displayed here. That's why we got Python and 40. But as soon as this kind of error occurs, like runtime error, where the variable a was not declared, then the interpreter won't proceed any further. It won't proceed any further. It won't read any further. It won't execute any further. That's why you see this particular string value welcome has not been printed. Okay. So then we move on to comments. Comments we have already seen. Print Python with a single invert commas. X is 15, y is 25, z is equals to x plus y. Print z. So Python will be printed. Okay, because here at first what we are trying to print Python. That's why here in the output console what we get Python. Then print z. Z is equals to what? It will be 15 plus 25. That is 40. So 40 has been printed. And then in between here we have hash w is equals to x minus y, hash w print y. Hash means again we know that is used for commenting. Here you can keep the here we are keeping the cell as code cell, but for documentation purpose or for commenting purpose we can use the hash. So these two things won't be printed. Okay. Then next is print welcome. This welcome will be printed. Okay. Then in Python, what is a data type? What is a data type? See, here like we have used for commenting purpose. Although I have kept the cell as code cell, but using the hash, I'm using the comment for documentation purpose. So what is a data type? It is the classification that identifies the type of a value. If you have a value, then that will have some sort of type. So data type is that classification which identifies which type of a value. And talking about classification, two types of data type we have. One is your basic data type, another one is your derived data type. Data types, I should say rather. So there are two types of data types. Okay, one basic data types and another one derived data types. Okay, basic data types are like, for example, integer, then float, complex, string, then boolean, none. All these are the examples of basic data types that we shall come into later. So basic data types are the ones which are like, integer, then you have float, then you have complex, string, boolean, none. These are the basic data types. So for integer, within brackets just for short form, int. Now an integer within brackets int is any whole number, whether positive, negative or zero, that does not have a decimal point. This is a very basic thing. Integer won't have any kind of decimal point. It can be positive, it can be zero, it can be negative, but it won't have any decimal point. Then it will be classified as an integer. So here, as you can see in this cell, x is equals to 15. There is no decimal point here. Print x, print type of x, print x comma type of x. Now, so when print x will happen, only the value of x will be displayed here, which is 15. Then here, print type of x. This is the type identifier which will give you that what type of a value it is. So as you can see, print type of x will give what here? Now it is of class int. That is the value here is nothing. The value stored inside x is nothing but your integer value. Class int means integer. Okay, and print, then all together I'm writing here print x comma type of x. Type is again the function which is used for identifying the type. It is a type identifier which kind of a value. So together if you print, then it is the value of x is 15 and type of x will give this particular output class int, that is the value of x is nothing but integer type. Okay, then here you have x is equals to minus 15, print x, print type of x. So print x will give the value of x which is minus 15, print type of x will give what type of a value it is. It is again integer type, class int, because there is no decimal point here. Okay, so if you run this cell and again you have x is equals to 0, print x, print type of x. So the value of x is printed here which is 0, and then type of x, that is what is the type of value that x holds. Class int means integer. And then another one is your float, another type of basic data type. Another example of basic data type is float. So what is a float? As we know, float will always contain your decimal point. Okay, so a float is any number, whether positive, negative, or zero, that contains a decimal point. For example, here x is equals to 15.6, print x comma type of x, it will give the value of x, which is 15.6. And what type of a value it is? It is float, decimal type of value, float. That's why the class is float. Okay, then x is equals to minus 13.7, print x type of x. Here you have a negative value. Like previously in case of integer also we had negative value. There was no issue. It was integer only. Here you have a negative value but a float type. A float type data type. Okay. So print x comma type of x shall give you the value of x, which is minus 13.7, and what type of a value it is? It is float since it contains decimal point. And then you say x is equals to 0.0. Here, although it is 0, we know that 0 means like even if we give 0.000, then it will be integer type, but that is not, that is not allowed here in Python. X is equals to 0 if you give, that will still give the type of x as integer. And if you write x is equals to 0.0, then what will be the type of x? In that case, it will be float value, because here you have a decimal point. That's why you see x is equals to 0.0. And when I'm trying to when I've written here that print x comma type of x, so the value of x is 0.0, that will be printed. And what type of a value x holds? Float type value, that is float data type. That's why the class is float. Okay, so here we had 0, and the class was int. And here we have got 0.0, so the class type is float. Okay, so that's it for this class. If you have any doubts, you can leave them in the comments. I shall answer them. And if you have liked this class, then kindly please hit the like, share, and subscribe button, and press the bell icon for notifications. We shall again meet in the next class. So thank you.